We continue Unit 10, Graphing Square Root Functions, with the last flap of our foldable. To graph a square root inequality, plot the points for the square root equation. We draw a solid line if it's less than or equal to or greater than or equal to, or a dashed line if it's less than or greater than. And we shade above if it's greater than, or we shade below if it's less than. The shading will stop at the end point. Let's look at some examples. Graph each square root inequality and name one point that is a solution. Example 1. Y is greater than or equal to square root of x minus 3 plus 1. We know that it is a solid line because of the equal sign underneath the inequality symbol. We shade up because the inequality symbol is greater than. Remember, to get our beginning point, we move right 3 and up 1. So let's plot that on our graph. Now let's find our movement for the rest of the points that we need to graph it. Remember, we multiply by our stretch in front or shrink. There is not one, so we use a 1. And we end up with 0, 1, 2, and 3 on the side. These are the way we will move our new points. So graph these on our graph, and this is what our new graph looks like. Now let's talk about shading. We know that we are going to shade up, so we will start at the beginning point and draw an arrow straight up. That's the side that we shade on, and we stop at the beginning point. We do not go past this line where our arrow was. Now we need to name a point that is a solution. Any point in the shaded region will be an answer. 4, 3 is a solution because it's in the shaded region. 5.5 up 4.5 is also a solution. It is in the shaded region. There are many answers. Let's look at example 2. Y is less than 2 times the square root of x plus 1 minus 1. We notice that it is a dashed line because there's no equal sign underneath the inequality symbol. We also know we shade below because this is a less than inequality symbol. Our new point is going to be left 1 and down 1. So we plot that point right here on the graph. And we have a stretch of 2. So go ahead and plot our points for the parent function and then multiply the y values by 2 to get the y movement. Now let's plot the new points. Starting at our new beginning point, 0, 0. Doesn't move, it stays right there. Done. Next point, out 1, up 2. So out 1, up 2 gets me right here. Next point, out 4, up 4. Next point is 9, up 6. So this is a graph that is going up. Now let's figure out our shading. Starting at the beginning ordered pair, we draw an arrow down and we shade on this side. Remember, any point inside the shaded region is a solution. 10, negative 10 as the ordered pair. But any of these points inside will be a solution. 5, 0 is also a solution. This point out here, not a solution. It's not in the shaded region. Look at example 3. In example 3, it's greater than, so we shade above. And there is no equal sign, so it is dashed. To get our new beginning point, we move left 5 and down 2. We also have a reflection. Let's go ahead and put down the points to the original parent function, and let's multiply by the -1 in front. And these are my new movement points. Let's plot our new point at -5 up to 0, 0, it does not move, 1, -1. So we go out 1 from here, down -1, out 4, down -2, and out 9, and down 3, and draw our line. Now we need to shade. This is a graph that's shading above, so we draw an arrow up. That is the side we shade on, so finish shading. Last move is to write down a point that is a solution. 10, 10 is a solution, and any number inside the shaded region is a solution. Example 4. Go ahead and pause your video, see if you can get example 4 on your own. Very good. This is the answer to example 4. If you have any questions, please ask me tomorrow. Thank you.